Dang!
Hello class, today we are learning about PVA.
PVA. Yeah, PVA. Yeah, PVA. PVA. Yeah. They call it PVA, speeding over across the way. My position is the key when I ignite my Hyundai. Velocity is second when the derivative is bound. Acceleration is the third, turn it all around. They call it PVA. Velocity, yeah. Acceleration, yeah. Here we go, yeah. PVA, yeah. Walking into class, call it Math Nation. Learning all about it, thinking that it's fun. Finding the derivative one by one, they call it PVA. Position, velocity, yeah. Acceleration, finding the derivative one by one. Walking into class, call it Math Nation. Learning all about it, thinking that it's fun. Yeah, PVA. Yeah, PVA. Yeah. We call it PVA. Call it PVA. Yeah. Going left, going right. Got that sideline all right. Picking all my points, gonna do it all night. PVA, yeah, that's right. Here we go. Whoa.
Okay class, we are going to do an example on PVA. Let's say Johnny is running along a horizontal line. His position function is given by x of t equals t cubed minus 9t plus 15t plus 2, where x is feet and t is seconds. So first we need to find the velocity equation and the acceleration equation. The velocity equation is going to be the derivative of the position equation. So it would be 3t squared minus 18t plus 15. Then the acceleration equation would be the derivative of the velocity equation, which would be 6t minus 18. The first part of the problem asks when Johnny is at rest. So what we have to do to find when Johnny is at rest is set the velocity equation equal to 0. So let's set 3t squared minus 18t plus 15 equal to 0. So we'll take out a 3 and then solve. So t equals 5 and 1. So Johnny is at rest at when t equals 5 seconds and 1 second. The next problem is when does Johnny change direction and why? So first we have to set up a sign line and put the values t equals 1 and t equals 5. Then you plug in values under 1, so 0, and between 1 and 5, let's say 2, and then after 5 we'll do 6. When you do that you get a positive value here, a negative value here, and a positive value here. So Johnny changes direction at t equals 1 second and t equals 5 seconds because when t is less than 1, he has a positive velocity. And when t is greater than 1, he has a negative velocity. When t is greater than 5, he has a positive velocity again.
First step off, set your equation equal to 0. About to solve the problem, about to be a hero. Negative, positive, yeah, change of direction. Now you feeling it, it's the math connection. When the velocity equals 0, yeah, it's at rest. Write it down, getting hundreds on that test. Make a sign line to get the question right. Notice a change in the graph, you just might. Remember, if acceleration 0, it's not sleeping. So will all of you quit beeping? Acceleration and velocity signs are the same. It's speeding up, yeah, it's not lame.
The next problem asks, at t equals 2, is Johnny's speed increasing or decreasing and why? So what we have to do here is set up a sign line and put the values 1, 3, and 5 here, because when we set the velocity equation equal to 0, we get 1 and 5, and when we set the acceleration equation equal to 0, we get 3. Then we're going to plug in numbers beneath these, so 0, 2, and 4 and 6 into the velocity equation. And you will get a positive value here, a negative value here, a negative value here, and a positive value here. Then we'll plug in these numbers into the acceleration equation. When you get a negative value here, a negative value here, a positive value here, and a positive value here. When t equals 2 and between 1 and 3, the signs match. So, at t equals 2, Johnny's speed is increasing because the signs are the same for v of t and a of t. Students, today our next lesson is distance versus displacement. Cody! Stand up.
Why?
Let's say you travel 10 feet to the left. And then you turn around and travel 3 feet to the right. What is your distance?
13.
Good. What is your displacement?
7.
Wow. Nice job.
Double D's, distance and displacement. The tricky questions creeping up from the basement. What's the difference? To me they just seem the same. When I get these problems wrong, I just feel lame. For displacement, look at the graph and you'll see what the true answer will be. Traveled up 8, down 2, up 1. That means displacement is 7 for that run. Now take the same problem, calculate the distance. Please don't be wary, throw no resistance. Do the absolute value of every room given, and you'll realize the distance is 11.
So, Cody traveled 10 feet to the left, and then he turned around and traveled 3 feet to the right. His distance is the total amount he traveled. Which would be 13 feet. His displacement would be how far he was from starting point. Which would be 7.
Yo, Ryan, drop that beat.
DJ Grid Squad. If you know the answer to the problem, yeah, you might think you're smart. But really, you haven't even begun to start. The key to get full credit is to state why. Be sure to tell the truth and don't lie. You first start by getting an X. But I'm about to tell you a secret. What's next? Put a prime mark there, it's a derivative. Then you state whether it's nega or positive. Just state what it's doing in the graph. Write it down with your pen. Get full credit instead of half. Because statements, yeah, they don't be easy. When you do it right, Mr. Yank is queasy.
What?